We'll go into questions afterwards. The
Cool.
only other note is that Max and I both have to leave at the 1 hour mark. So sometimes our talks go over a bit, but this will not be one of them. So
I
please,
mean, that would take us to 11 p.m. So I'm probably quite keen to also leave at the 1 hour mark. But we'll,
okay, great. Yeah, well, please,
well, maybe that won't be the case. But like,
yeah,
there's some degree of alignment to that.
sure. Well,
Let me
thank you for
try and
joining
figure
us.
out.
Please take it away. Yeah,
I'm now going to. I have not used Zoom on this Mac before, so let's try and not fuck up screen sharing. It's going to be great.
yep.
I would like to share desktop too, maybe. Hi, gaming. Did that do the thing? It looked like it did some.
Yeah,
Can
looks
you see
good.
some slides?
We see it.
Cool. There's a header bar in there, but we're just going to live with that. No, that's worse. Professional. Cool. Let me get that out the way. Lovely. Cool. Hi. I'm going to hi everyone. I'm Issa. There is actually Who Am I slide. I'm preempting myself there. I'm going to talk to you about some work I did to figure out how UK mobile rail tickets work. This is the slightly dubious talk version of a blog post I did for this work that you did see already, at least the organizers of this saw already. But yeah, so hi, I'm Issa. My pronouns are she, her. I am a bit of a train enthusiast, if you hadn't guessed already. Actually, the much bigger train-related thing I do is this London Underground data project called Intertube, which, like, hilariously involves, like, a whole bunch of graph theory and stuff, and would probably have been more interesting given this audience. But anyway, yes, and my day job is completely unrelated to any of this. And actually, the funny thing is I'm not really necessarily a security person by trade. I am just a train nerd. The other important thing to note is this was by no means a solo effort. I was very fortunate to have a bunch of lovely friends help me out at various stages, who are these lovely people, and I will be highlighting where they made contributions as appropriate. Right, I should have thought about this. This was originally given in Cardiff, and the UK is not like the US and people use trains a lot more. But so if we pretend we're in Cardiff, I would be asking this rhetorical question about what ticket people had used. And in the UK, there's these paper credit card size tickets if you buy them from the local vending machines. There is a smart card scheme. There's this standard called ITSO that's like this national standard for smart cards, but no one actually really uses it, and it's kind of been a bit of a flop, but it's worth adding for completeness as one of the ways you could pay for tickets. But I think probably one of the most popular ones is this barcode thing that people can buy on their phones. You can also print these off online at home, and actually some ticket vending machines are now just selling the barcodes as well. And this is going to be our focus today. So I am rather partial to the paper ticket format. You can do this neat thing with them when you start collecting them if you're really that much of a nerd. And they kind of look cool. And the thing I really like about this is you have this automatic log of all the places you've been, which is quite nice as a sort of automatic journey log you don't have to think about. But I was looking at this one day in December 2022 and sort of went, wouldn't it be nice to actually like analyze the journeys I've made? Like I can't make a version of Spotify Unwrapped, but for rail journeys very easily, like some sort of statistics on frequently used stations. I'd have to go and like manually like page through the thing and enter it all in. And then I remembered that these things exist. And I was like, what if I just used like mobile tickets for my journeys and then figured out some way to get data out of the barcode? Then I could do like cool automated stats. Like it's machine readable, so that should be fine, right? So that's the idea. I like collecting tickets. Can we do automated statistics based on the barcodes? Like surely this has been done, right? Like this is one of the first things I thought. Surely I must not be the first person to do this. If we look at our ticket again, the barcode in the middle is known as an Aztec barcode. Importantly, it is not a QR code, as some people and occasionally train companies will insinuate. It's not a QR code. So you put into Google, this is my first instinct is you just Google it. How do I decode a Rail Aztec ticket? And you actually get the Stack Overflow link that says, oh yeah, Aztec codes contain railway tickets and encoded according to the specification, this UIC 918.3 standard. And the UIC is this international like railways body. So it's like, maybe they use that. There's this German Wikipedia talk page that like goes into what this is. Turns out people have done some work on decoding the standard, which is good. And there's even some fancy GitHub code that the Germans have already written that's even like takes the barcodes out of the PDF. Like, at this point I was very convinced that people had done my job for me and this would be easy. Just use the built-in tooling from the GitHub with the barcode and it's going to be great. It's the other. If it's a standard, surely the UK would follow suit. It's not as if the UK has ever, not has deliberately the UK loves diverging from the continent on all sorts of things, but that's definitely not happened here. But yes, it was nowhere near as easy as this. Otherwise, I wouldn't have this talk to give. If we take the ticket again and actually read the contents of the barcode, we get this seemingly random jumble of mostly letters. This doesn't look like the UIC ticket format mentioned in the German thing. And it's kind of unclear how you'd really take a start at decoding this. There's nothing obvious, there's no real obvious structure that jumps out as to how you'd start, which is kind of depressing. The one hint we do have is the ticket starts with this sort of magic string 06, which in combination with a bit more Googling reveals this is actually a like RSP-6 standard ticket, which isn't public. So some people, there's some references to it, but you can't actually get the PDF. The first question you might have, especially if you're familiar with sort of UK public bodies, is what about the Freedom of Information Act? And someone did do a Freedom of Information Act request to the Rail Delivery Group, the body responsible for this, asking for the spec, which they refused. They kind of just ignored it as soon as the person said, they're like, oh, are you working for a train company? It's like, no, I'm just a guy. And then they're like, no, you can't have it then. And they are allowed to do this because they are not actually legally subject to the FOIA, which is quite sad. So we're basically on our own as far as figuring out how to decode this. There are a few tricks we can try. The first thing I did was I read those like cool security, like reverse engineering blog posts where they use this tool called Binwalk. So I was like, oh yeah, I'm going to use Binwalk. I'm doing reverse engineering, right? I don't actually know what I'm doing. But yeah, so it has this mode where you like do tac big W, and then it will compare like two binary files. So you can see if there's like any bits in common, which can be nice for trying to figure out the structure. So we do this, and unfortunately we get mostly a sea of red, indicating no match. There are some like shared headers. So, maybe there's a header block, but the actual bulk of the ticket seems to be like mostly random or like not shared. You might see that there are some like bits of green. So you might think, oh, there's some shared bits, but actually if you add in another ticket, it becomes evident that that's just like a coincidence. So we're basically on our own, and there aren't like obvious similarities that we can divine just from looking at the data and like getting a whole bunch of them comparing. It's entirely possible that the ticket might be somehow encrypted, preventing us from really getting at the data inside. And even if it wasn't, this was like somewhat disheartening, given there wasn't really any sort of obvious place to go from here. Now, this is where one of my friends, this like lovely wolf friend of mine, Harley, also known as Unlabito, she notices that I've been talking about this somewhere and had a suggestion for me. This name of a ticketing company called Misabi. If you go to their website, it turns out these are the people who invented the mobile UK rail ticket back in 2007 by partnering with the Chiltern Railways Railway Company. And they have a suite of inspectors tools called Just Ride Inspect that can be used to scan these tickets with apps for iOS and Android. So now we have somewhat of a lead. It turns out there is actually this company that's invented this, thanks to a friend. And there are some apps that can decode the tickets that the inspectors presumably use. So can we just get a copy of the inspector apps and play around with them? So you can't get them on the official Android, the Google Play Store, but really that's kind of a minor roadblock. There are usually other sort of shady sites that can fix that problem for you. So we get a copy of the app, we run it inside the Android emulator, and it's not very interesting. To do anything, it wants you to scan a configuration barcode or log in, neither of which are things we can do. I did go to the effort of like actually passing through like a fake camera source into the emulator and trying to get it to scan like a barcode. I have a screenshot of that. You can see I'm passing through some text. It wouldn't scan regular tickets at all in this state, which is quite disappointing. Like there wasn't really anything we could get out of that. If you hit the login button, it gives you this list of like Athens Transport Organization, some train operating companies, and some that have gone defunct. I don't work for any of them, much less the ones that have gone defunct, so I can't log in with any of these. So running the app was maybe slightly interesting, but ultimately didn't lead us anywhere really useful. So what else can we do? Well, Android's app development IDE, Android Studio, has a button in it called Profile or Debug APK. So maybe we can just give our app to that and it'll show us what's inside. Maybe there's sort of some built-in tooling with the Android platform that will help. If you do this, you get this kind of thing that looks like it might be useful, but it's actually not. It has given us a bunch of these weird like .smiley files instead of the Java source we might have been expecting. So what's up with that? To answer this, let's briefly take a look at how the Android build process works if you're not familiar. So when you build an Android app, you usually write the source code in Java, and then it gets compiled into this optimized sort of bytecode form. This is like a bit like what a normal C compiler would do, right? You have your source and it gets compiled into bytecode, and then you package that up into the final APK, which is the package you install. These Smiley files are just a human readable interpretation of this like bytecode, right? It's like, I guess assembly files are sort of disassembled like object code. So this isn't very useful. It's this is intended for the Android VM to read and not us. And as part of the compilation process, if you're not already familiar, information about the original source code necessarily gets thrown away in a bit. You don't need all the stuff in the Java source to run the program. So, from sort of that perspective, why would you include it? So looking at the APKs and sort of the built-in tooling is kind of fruitless because you only get the bytecode. This is expected that you have the source, so it will ask you to link the source, but you can't. The tooling provided with the development environment doesn't really let you reverse that process easily. So you can't ever recover the original source from bytecode, but you can definitely take an educated guess. There are tools out there that will take such a guess. One of these tools is a core utility called JADX or JADX, available on GitHub from this user Skylot, which advertises that it can decompile bytecode to Java classes from APK files, which is like exactly what we want. So we run it, we download and run it, we pass the APK to it on the command line, and it actually dumps out some Java files. So it dumps out an Android Studio project, which looks great on first glance. You might notice that some of these files look normal and some are slightly scrambled, like there's some that are like C2498A. And indeed, this is a larger problem. When you go and look at the code, all the names are kind of missing and replaced with these made-up jumbles of letters and numbers.
I was hoping for this to come up. Most of the apps that are deployed have obfuscation. Code
that was literally, yeah, exactly.
Yeah, I was waiting for this.
Yeah, I mean, this. I apologize if a lot of this talk is covering stuff that like you already know. This was designed for a.
No, this is great. It's great.
Yeah, sure. All right, sure. But yeah, so yeah, it's obfuscated. If you don't already know that, they, in addition, just compiling the code, which in Java actually usually does keep the names of sort of classes and methods intact. Android developers usually deliberately go and obfuscate it, changing around what classes, methods, and variables are called. This is mostly done for size reasons. Well, there's no point bloating your APK with long names that are only useful to people writing the code. The code will run the same if something is called A or if something is called ticket inspect activity. The obfuscator shortens it because it can. It also makes people like me, that makes my job harder, which is, for some people, maybe the main benefit. The weird letters and numbers things are actually the decompiler tool, JADX, helping us out a bit by taking the original obfuscated string, like A, and adding like an M for method or a C for class, so you can tell what sort of thing it is, and adding a random number so you can like differentiate different things called A, which is nice. So there are some tricks to undo this process. It mostly just sucks. Some of the tricks, like if you look at this code here, kind of no prizes, you can actually guess what the class and method are called because there's this log line that just includes it. So instantly we now know that this class is called datetime_utils and that method is called packdate. Thank you, that's nice. But yeah, basically it's a lot of like basically an afternoon of sitting down. It's kind of a nice puzzle actually. If you should try this. The IDE has this nice feature where you can actually hit rename on something once and it will propagate that across the entire code base. So mostly it's just sort of figuring stuff out, letting the automated tooling do a bit of a rename, and then it gets easier to read and you can do it incrementally, which is quite nice. It just takes enough for me. Just takes, maybe about 6 or 7 hours total. And then after that you get what is basically good enough source code. Well, with my own naming scheme instead of the official one, of course, it's not the original thing. You can't easily recover that, but yeah. So for example, we can see the class that does this RSP6 ticket decoding, which has a bunch of interesting functions like decrypt ticket payload, an RSA decryptor, some stuff for seat reservations. So actually I mentioned RSA, and we should probably briefly cover that part. There is actually some cryptography used to secure the tickets. It's not even the worst thing you could imagine, which is, pretty good, pretty surprising actually, for sort of homegrown crypto. I'm not actually, I say that I'm not actually necessarily that qualified. Maybe a cryptographer will show up and find some massive hole. But yeah, it works like this. Your issuer generates a payload here in gray with all the actual data inside it. They use their private key to make a signed ticket, which actually goes on the barcode. And then the inspector uses their public key to get it back out and verify it, and then use the data inside that for inspection. So you've got this kind of nice, kind of typical public-private key system that means that without the private keys, you can't actually go and make your own tickets, which is nice. So they did sort of think of that. There are a few quirks. It is literally plain RSA with some padding, with PKCS1 padding, which is probably somewhat frowned upon, I'm given to understand. Like literally the code to decrypt it is, well, to decode it is you take the payload as a big integer and you do the RSA like raising to the exponent and taking the modulus thing directly on the payload, which, is fun. The ticket is inside the signature. As a sort of non-crypto person, I was used to signatures being a thing where you still have the plain text, you hash it, and then you put the hash, you sign the hash thing and append that. That's not how this works. Here, the entire thing is inside the signature, which obviously limits its size, but that's actually fine because they're all this sort of fixed small size anyway. So unfortunately, that also means that the public keys are required information to decode the tickets at all. Which explains why we couldn't get anything out of running binwalk earlier, because it's all some RSA signature. Despite the name, the public keys are distressingly non-public. The Misabi app just downloads it from the server when you log in with the config barcode, so that's kind of sad. Although they also just left some in. These aren't referenced by the running code. My best guess is that they just like forgot to include them when packaging the final thing up, but that's kind of nice. The thing that isn't that kind of nice is this was from 2016. So we've got some keys, we're missing quite a lot of keys because, the UK's rail industry is complex and new train companies appear to replace old ones, and actually more of them adopted ticketing, sort of mobile ticketing in that time. And then this is where actually another friend helped out. This is my friend Park pointed me towards yet another validation app called TTK Mobile for the iOS platform, which is actually, it's still available on the App Store. You can just download this. If you download this, this is what it looks like. I don't have an iPhone, this is a friend's screenshot. If you hold down that camera scan button, you can like point it at a ticket and it will like indeed decode it, or at least it used to. And actually, the friend whose phone this is, Eva, spent some time running it behind a proxy and found out that it actually just downloads all of the keys from a server unauthenticated, which is quite nice. You don't have to do much work. You could just curl the thing and it would return all the keys as JSON. This is now fixed, unfortunately. But at the time, this was very useful. And it's kind of unlikely that they're going to rotate their keys. So there's a copy that you can have that is publicly.
Wait, sorry, can I interrupt with one question real quick?
Yes, yeah.
That's interesting. So these are public keys
yes.
that you were able to find and aren't changing, but they're trying to hide them. You have, so first of all, I love that this is potentially because of your work that they were like, oh crap, let's hide these things. But also, why the hell do they want to hide this in the first place? If you have any ideas, and if not, you can just keep going too. That's fine.
So, I mean, I don't think they actually, they didn't hide the key specifically. It's more that I reported another unrelated vulnerability in their app that I'm going to get to. And I think they just went, oh crap, let's lock the whole thing down, rather than specifically saying that they wanted to hide the keys. I don't know. I mean, they're generally, my perhaps like unjust impression is that they're not really that keen on, I mean, they didn't make the spec available, right? So like, I don't think they're that keen on people sort of getting at this data in the first instance. It is kind of annoying, but yeah, I don't know. I guess they're just kind of capitalist and don't really, I know.
Okay, cool. Thank you.
That's fine. But yeah, so we can get the rest of the keys, or at least you could. But there's, as I said, there's a JSON copy inside the repo that you can clone if you want them. And I assume it would be effort to go and roll the keys on all the ticket validation stuff that exists out there. So hopefully, especially since they are just public and you can't actually you can't make your own tickets with this scheme. So it's unlikely that they'll go to the effort of rolling them, and maybe you haven't. Oh, there's a chat. I should perhaps be monitoring this whole time. Whoops. Yes, it is just public keys. There's no private keys. This would be a far more interesting presentation if there are private keys as well. Right, yes, we can also take apart the TTK mobile app with Gydra, or the NSA's reverse engineering tool, which has lovely Objective-C decompilation support, and that lets us get a few of the extra fields that the Misabi app didn't include. So here's the bonus thing that I sort of was going to cover earlier. There's I guess none of you live in the UK, but they do have a lot of ads for switching, ditching your old paper ticket and switching to mobile, which isn't just because it's more convenient for you, it's also more useful for them. It gets a lot easier for them to detect fraud this way because all of the barcode ticket scans get reported electronically, and there's like code to do this that I saw while decompiling. There's this electronic ticket validation database. It stores actually almost a distressingly large amount of data. The inspector ID, the train ID, the like lat lon of where you were, the time, the barcode, the scan result. Like there's a whole bunch of stuff, which really useful for fraud detection. If you want to detect people doing things like short faring, like buying a shorter ticket for the journey they actually like. You can do this like thing that I'm not endorsing at all, where you buy a ticket that doesn't cover your whole journey and hope you just get inspected for the part where your ticket is still valid. So I can imagine this is very useful for detecting that kind of trick. But yeah, so this incredibly detailed, presumably kind of anti-fraud data was also just provided unauthenticated for a while, which is pretty scary. So you could just hit this endpoint and get, a bunch of stuff. This is one of my own tickets. But yeah, latitude, longitude, train like ID, departure date, the actual full barcode, info, the username of the inspector, which was actually their name, whoops, and a whole bunch of stuff, and the fact that I had a rail card. This was also useful for checking my work because, as you would have seen, it actually decodes some of the fields, which is nice. But yes, I reported them and they did fix this because that's kind of a problem. But yes, so I can now unwrap tickets from the sort of RSA signature blob with the public keys. I can figure out what most of them mean, the overwhelming majority of them mean based on the reverse engineered app. So I'm basically done. There is a Git repo with this like hackily thrown together table showing what all of the fields are. It's basically like it, because I mentioned earlier, it's just like one fixed width blob inside a RSA signature. It's very densely packed. So these are actually indices into, like, you treat the entire thing as a massive bit field and like do bitwise operations on it, which is kind of cute. There is also this website that I put together that will decode them, that I said I would demo and did not mentally prepare for doing that. So I might do that after I've done the main talk bit in a second. But yeah, that is the end of the slides that I have. Please ask me questions if you have any. Yeah.
That was awesome. Thank you so much.
All right. I might actually try and, I don't know if I can put together a demo.
Yeah, you can do the demo if you'd like. If not, we can just go into questions too.
Feel free to ask me questions while I'm like screwing around with this, I guess.
Sure.
We can do that.
Okay, so one question I have to start is you mentioned disclosing a vulnerability. Is this not shared in the talk so far for logistical reasons for them, or did I miss it, or?
It wasn't. So the vulnerability, sorry, was just that the ticket validation data stuff was completely unauthenticated.
Oh, right.
I should have made that more clear.
Okay.
Yeah. So that they locked down access to their API entirely to unregistered devices. Whereas before, actually, I emailed them and they were really lovely about this. The blog post sort of mentions this. They were very friendly. They were like, oh, it's like cool. Like, why are you doing this? I'm kind of interested. We wanted to actually make the intent was to make the app accessible to unregistered users, because they were like, yeah, people might want to check their own tickets, especially if they've got like a season ticket and want to like see how many instances of the ticket they've used. But then they agreed with me that actually it was probably a bad thing to have all this data available, especially since it wasn't as anonymous as they'd hoped. So they did then just go and lock it down.
Cool.
I think mainly because they had better things to do, and they were like, yeah, this is probably a minefield, so we're just not going to bother providing this service.
We'll just hide it. So did you accomplish your original goal of being able to see for all your new tickets where you've been and stuff and have all this data?
Yeah.
And other people can jump in with questions too.
Yeah. Like I should actually just do the demo thing. I wonder whether I can. This is a Mac, and this is so on the or maybe I can download. When I gave this talk in person, I used a tool called SCR-CPY or Screen Copy. That it's in Homebrew. Great. Okay. So I'm really flying by the seat of my pants here. You can tell I'm very good at doing talks and I'm-de-dum. Yes, the website thingy can actually decode tickets pretty well, which is nice. And I have started using the e-tickets, and like you can, because the website also gives you the like raw barcode string, and it also accepts that again. So you can like absolutely just copy paste the string and like build up a text file with all of them if you really want to. And it's also a Rust crate as well, so you can just import it and use it programmatically.
Yeah.
And you get like a JSON blob.
Okay. That's really cool, Ida. So I'm curious, how much of this were things that you'd been exposed to before versus a big exploration of a project? Because you explained everything very well. It seems like you're super knowledgeable about this huge array of topics, and I'm curious what that process was like.
I don't know how much of this is just kind of, you know, like your sort of stereotypical reading lobsters or hack and use and just kind of being exposed to a whole bunch of stuff passively. Yeah, I mean, like I sort of like jokingly referenced this. Like I'd heard of people using tools like Binwalk and stuff, and like I had a like rudimentary understanding of, well, you know, I knew what a compiler was, as one would hope, given I kind of do this for a living. But yeah, it was kind of I guess maybe an even mix of just sort of vaguely knowing what to do and sort of muddling through it as I was going along. Yeah, I think I mentioned this in the email. I didn't really do university, so I'm like very accustomed to doing self-directed stuff, which means it's kind of harder to have some obvious thing to point to when people are like, "Oh, how do you know how to do this?" I was like, "I don't know."
No, it's cool. It's cool.
That's not very helpful.
No, it's fine.
Be able to be like, I don't know, just like hang around and like read some stuff, and like if it's interesting, do the things. Probably don't use me for career advice. Oh gosh.
Jacob, I learned this a really long time ago, and I forget the exact answer. I think it has something to do with like payload or size or something. Can you explain why it's stupid to use RSA for everything? Like, I know you're supposed to use RSA for the keys, and then use like AES 256 for everything else.
Yeah.
Why is that?
So I think RSA is an asymmetric cryptographic system, and AES is faster. So I think people usually do something like RSA so that you can set up a key between yourselves that is a shared secret between you both, and then you can each use that for a whole bunch of blocks and churn through them quickly. So I think it's a speed thing. I could be mistaken, but the AES is quicker when you already have a session set up. It's great, and RSA is good for setting that up. I hope that's not totally wrong, but that's
I mean, I'm not. I'm also clueless. One important reason that I totally just found on like this cryptography equivalent of Stack Overflow is like the math doesn't work out. You can't actually sign, or you can't do RSA operations on messages that are longer than your key length, which is a problem. They solve this problem by just having the payload be smaller than the key length. So they don't run into this. But like, yeah, I guess for arbitrary, you know, normal like stream cipher stuff, that is kind of a big issue.
Okay,
so they just do RSA and then they like one-time pad their, or they XOR their message with their key or something stupid like that, probably. Right?
No, they literally just do RSA. Like,
oh, okay.
They have the private. They do the modulus exponent thing, and that's it. Like they pad it out, add some like ones to the start, which I think corresponds to some spec, and then they like stuff it into a big int, and they do the modulus exponent thing, and that's it. And then you do that again to undo it.
That's kind
of like, no.
Okay, so I have one other question, and people, please, you can raise your hand or something if you would like. I don't want to talk over everyone, but one interesting piece that was sort of an assumption from the very beginning is when they had this Aztec QR code, somewhere in your head, either you thought, I bet there's interesting data in there I can use. And was there any particular reason to believe this, or you just sort of assume, like, based on how this stuff is designed, I bet they just threw it all in there? I have my own anecdote and story about this type of thing afterwards, if you like, but I'm curious about that.
Yeah, no, that sounds interesting. I mean, I think it's mostly that, like, this isn't just so if you get inspected on a train, this will be people with Android devices running the TTK mobile app, which is quite funny because I now, like, after doing this, I now have like a newfound appreciation from like, I can see the brand logo on your thing. It's like, I know that. This is probably you shouldn't mention non-public transit out there. It's like if you're a very weird look. But yes, so there's people with the mobile apps and the scanners, but this is also on the gate lines, like the automated gate lines. And so a lot of this was like those things probably don't have reliable internet connection.
Yeah.
At
Okay.
least the Oyster system in London is designed to operate without like reliable internet connection. Like it's asynchronous, and they like do reconciliation after. But like when you scan an Oyster card in London to open the barriers, it doesn't go and like do a synchronous API call. It will batch download a list of blocked cards, and then it'll communicate with the card in some cases to figure out whether it should allow it, and then it will like report what it did afterwards. With the idea being that it would be way too slow to have to hit a server, and then obviously if the server goes down, no one can travel, which is bad.
Okay. That's
I guess
clever.
I guess that was the assumption. It was just like, yeah, I mean, things generally aren't going to hit a server for every like validation, because that would be really bad and like slow.
Right.
So
Okay.
there probably must be at least some degree of necessary data inside the ticket.
Okay, that's fascinating. Yeah, so offline nature of it means that it has to be there, and if they
Yeah.
don't just have an ID that gets sent off to a server somewhere, then
Yeah,
it's
exactly.
cool.
That would be
Which
very
also
surprising.
makes their fraud detection quite challenging.
Yeah.
But
Well, so
yeah,
that's the validation records get batched and sent to the thing. So yeah, that would be after the fact.
all right, looks like Caleb has a
Yeah.
question.
I mean, I should answer there are many questions.
Or Jake, sorry, yeah.
In LIFO order.
Yeah, go for it.
Legal action. I did kind of. There is a reason I responsibly disclosed this first and very much held off on it. In the UK, we have this lovely bit of legislation called the Computer Misuse Act, which is very vague, and it's like, yes, if you do damaging things to the computer, that's very criminal. So I was very much like, I was really just going to post this without even notifying them, being like, well, it's public information anyway. And then I thought about it, and I was like, no, that actually could end up really badly, because if they took it badly, they could absolutely try and go after me. Thankfully, they turned out to be good sports about it. At least the company whose thing I sort of found that was public. I didn't really worry about like being able to read the stuff already on tickets being like a problem, because I don't know, that just sounds like a ludicrous thing to get like legal action over, and like honestly at that point I wouldn't even be mad. That's ridiculous. I guess the UK is less overly litigious than the US. It's a sort of societal difference, so maybe this is something you guys think about more. But yeah, this was very much like a I held off on publishing this for actually quite a while until they were sure that they either had patched. Oh, I think I gave them like a month and they still didn't do it, and I'm like, okay, they clearly don't give that much of a crap, so like, cool. I'm probably not going to get them coming after me for this.
Edo, was this your first time reporting a vulnerability, or had you reported vulnerability?
Yes, it was.
Okay. I also, for the first time in my career recently, reported a vulnerability, and I with Ankit actually, and it was an interesting experience for us in the same, like precisely the same way, in the sense that the people we reported to were totally cool about it, and they're like, yeah, so we're like not going to fix that, which was kind of fascinating.
Yeah, I mean, yeah, I guess like that's the thing, right? It's like, especially given that I was new to this and presumably had this experience as well, it was very much like, oh shit, am I going to get sort of in serious trouble, or is this going to be like an actual big issue? So it is always nice when they are nice about it.
Ida, are there any other projects and explorations like this that you're currently working on?
What am I doing with that? That's a great question. No, not really. I'm gonna. I think this is where the it's 10:30 p.m. is kicking in. By the way. Yeah, no, like I don't. As I said, I don't really do security stuff as a matter of course. Like, yeah, I feel like I might have had some sort of. Not really to this degree. This was just sort of something I kind of got interested in and like spent an afternoon like picking apart the app, and I was like, oh, this is cool. I did make reference to, I have this like this like London Underground open data project that is not that's not reverse engineering, that's just engineering.
Oh,
I mean I can maybe screenshot this thing. Done.
what's this project about? You're sharing. Okay, perfect.
Yes. Yeah, this is so the Transport Authority in London, TfL, provide data about their London Underground trains in a kind of crap format. So they provide departure boards, so you can ask for the trains arriving and departing at a particular station. This thing scrapes a whole bunch of them, combines them, and like lets you follow the history of individual trains. So if you like click on a line, it has this like nice diagram, and you can click on an individual train, and it shows you the history of where this train has been. And this is like a whole thing that I like gave a whole talk about at EMF. That some people have described as a graph theory lecture by the back door, because not as I said, I'm not really that much of a university person, but I absolutely ended up like trawling through Wikipedia to be like, oh yeah, I bet some people have solved this already, because it does like a whole bunch of complicated bollocks with trying to figure out what the network model looks like. I could sit there, like I have a tube map on my wall, and I could like sit there and try and program it in, but I was like, I'm lazy and that takes effort. So instead, what I'm going to do is I'm going to like have a whole bunch of observations about where trains have been, and then I'm going to like try and like mesh those all together to create like one big graph. And then there's a whole bunch of interesting filtering steps that you have to do to get this to work, because the data quality is kind of crap.
That's super cool.
But yeah, that's the other like main train project I do. And like I guess I'm like I find it slightly interesting that the thing that I spent quite a lot of effort doing was not as popular as the thing that I was like, oh, that's interesting. Let's just like spend a weekend fucking around with train tickets, and then that's the one that people care about. But I guess that's a lesson about something.
No, that's cool. Is there a blog post on this one you were just discussing as well?
There's not a blog post. There is a video that I can find and dump in the thing.
Yeah, please share a link with that. And then I'm actually
if you found a graph from the sequences of stops that trains had gone through, doesn't that essentially mean that you synthesized an automaton from the traces of the automaton? Ankit or Daniel?
Those are computer science words I don't understand.
Ankit, can you weigh on this? Did they just do synthesis? I'm thinking this is a yes.
Who does
Caleb says he. I don't know if that.
Sorry, I missed. Who does synthesis?
So if you generate a graph knowing only runs of the graph, is that not equivalent to synthesizing an automaton knowing only words in the language of the automaton?
It is.
Yeah, okay. So you did something very cool from a formal methods perspective as well.
Yep.
Which is interesting. Yeah.
This is seemingly a recurring career thing, because like with the first job I had, I dropped out of university to go do a job working for a database company called ReadySet. That apparently is doing some, well, not apparently, is doing some like is doing some cool like sorry, I'm quite slow at this time of night.
No, it's fine.
They compile SQL queries into like a data flow graph and do a whole bunch of it. There's like this whole paper on this. It was like someone's PhD thesis, and then they were trying to productionize it. And so I ended up doing a whole bunch of extensions to this that like some people are like, you could publish this. It's like, I don't know, I'm just writing code. Like I'm sure you academic people can like find a way to make a paper out of lots of things. I just like
we just got skewered.
I know. But yeah, so to use some more graph theory, I mean, you should maybe watch the talk if you're interested in this sort of thing. It does lots of topological sorting, basically, because you have this problem where, because it is scraping departure, because you do not get every like state transition, you kind of miss, like say your like actual underlying structure is like vertices on a line, like A connects to B, A, B, C, D, E. You might observe like A, then C, then E, or then like B, then D, because you're polling and it actually moves more frequently than what you can capture. So I do like topological sorting to try and guess what the original structure looked like. And then there's like this code that I'm sure some like people who know what they're doing would be really upset about, where I do I think it's like Kahn's algorithm, like the one that finds cycles, and then I'm just like, I'm going to break one of these links because I can't topological sort of their cycles. So like, look for some cycles, look for the one that looks the most sketchy, and then break it somehow, and then do it again, and just kind of ram the thing until it works. Which is like, yeah, it works, kind of.
Cool. Well, does anyone else have any questions? Because I'm done with mine, which is
I did have a
unusual
demo.
occurrence.
Oh
yeah,
I think I
please
can
go for the
actually
demo,
get this to
like-
work. Yeah, here we go. Let me do the Zoom screen sharing of the thing. Yes, share. Cool. Can you see that? Oh crap! I actually need tickets now. Oh wait, there's an example ticket in my slides. Haha! I thought of
It
this.
looks good.
Cool. So if I just prepare my screen, yeah, I hit scan now. And point it up to the thing. Come on. Yay! Okay. So like it decodes. This is a ticket from Cathays to Cardiff Queen Street. There's the station codes. It shows you what the fare is, the class, ticket type, the ticket reference, the price I paid for it, when it was purchased, who the vendor was, basically all the information in the ticket. You can hit the JSON thing and it gives you like the JSON blob that the library spits out. And then there's the actual barcode text. So this is kind of neat as like a way to like decode your own train tickets using my reverse engineered stuff. And you can upload a screenshot and paste in like raw text as well. So yeah, that's that.
I feel like maybe we should
That's
let you
neat.
go to sleep at some point in the
No,
near
it's fine.
future.
I mean, I blocked out an hour. This is okay.
Okay.
Although I did yoink the gov.uk design system. I mean, Institute also yoinks the like the gov.uk for the context is the UK's like government. I like and there are like especially with the way the UK is going recently, there are very few things that make me proud of my country, but like our national infrastructure for like interacting with the government is pretty good. And like they have like a whole bunch of really nice design standards. They're trying to homogenize it all. There's like they are very good at accessibility, as Kayla points out in the chat. And it's all MIT, so you could totally just clone it and look like the government, which is good because it's a good design system. So it just uses that because this was very much thrown together in a weekend. It also, I didn't want to like rewrite the Rust code that I'd written in JavaScript. So it's just compiled to WebAssembly and then shipped as like a blob that then has some like hacky glue code. So, but yeah.
That's awesome. I love it. Okay, so unless anyone else has questions, please interrupt if you do. I think this will be the end of our talk.
There was how do you use Gydra? The answer.
Oh yeah, please explain that in a few minutes.
I didn't know how to use this either. This was my first time using this tool. I like loaded it up and I clicked buttons until it did what I wanted. Again, very much, I don't know, just like, yeah, you have to create like a project or something, and then you like add the binary, and then there's like some analyzers you get to choose, and you like pick the objective C1, and then you can like it generates a symbol table somewhere, and you can click on the function that's like decode ticket. It's like, yeah, I want that one, and then it like it didn't spit out like the best code, but like with prior knowledge of what the thing was supposed to look like, I was like, yeah, that looks like the bit index that I got from this other step, and then the function after it is calling it this. So that's enough. Like I was just using this. I didn't go into that in that much detail because I didn't actually know how to use Gydra, and I didn't use it in that much detail. It was very much oh, that bit index probably corresponds to this, and it's probably of this format.
Yeah.
But yeah.
Cool. Okay. Well, thank you, Ida, for coming to talk with us today. This was a wonderful presentation, and it's fun to learn about the different projects that you're involved in as well. I'd love to see blog posts about that, or maybe I'll just watch the video.
Thank you so much.
Thank you so much.
Cool.
Okay. Adios.
Thank you.
Yeah.
Bye-bye.